At 3:08 am, the floorboards were still. The refrigerator clicked once in the kitchen. Beneath both, the planet kept a secret rhythm. This story begins with earthquakes that repeat, not perfectly, but close enough that scientists hear when the same path stops sounding the same. Imagine a locked room under your bed, 3,000 miles down, sending echoes through iron, mantle, ocean, concrete, carpet, and bone. Scientists cannot visit Earth's inner core directly, so they study seismic waves that cross it after large earthquakes and arrive at distant instruments. Those instruments sit quietly for years. Small boxes in locked rooms, metal legs on concrete, sensors listening long after everyone has gone home. The recent Nature Geoscience study examined inner core crossing seismic records from 1991 through 2023, searching for changes across decades of repeating signals. Repeating earthquakes are useful because they behave like the same knock at the same door, night after night, from nearly the same place. USC reported that the study used waveform data from 221 repeating earthquakes at 42 locations near Antarctica's South Sandwich Islands. Out there, the sea is black most of the year. Wind worries the water. Under it, faults slip, reset, and slip again. Because those quakes start so similarly, altered waveforms can suggest something changed along the route the seismic energy traveled beneath us. That is the uneasy part. Not a crack opening in the street. Not a warning siren. Just a line that arrives slightly wrong. A waveform is a shape made by motion, a record of pressure and time, a memory of stone written without words. The inner core lies about 3,000 miles beneath the surface, wrapped inside the liquid outer core, and buried beyond any drill. We stand above it making coffee, arguing in kitchens, sweeping crumbs from tile. Under all of that, iron sits in unbearable pressure. The Smithsonian described the inner core as a mostly solid iron ball roughly 1,500 miles wide, with changes appearing near its boundary. For a long time, that hidden ball seemed easy to imagine. Solid, centered, patient, a weight at the bottom of everything. But the study argues that wave changes may reflect both a shifting rotation rate and local action near the inner core boundary. Rotation was already strange enough. A world inside the world, turning at its own pace, like a clock behind a wall. Scientists have debated whether these signals show the inner core rotating differently, or whether its surface itself has been changing. The new answer is not neat. It is worse in the quiet way. It may be both, happening together beneath our feet. The near surface of the inner core may undergo viscous deformation, likely shaped by the turbulent liquid outer core. Viscous is a careful word. It does not mean melting away. It means matter yielding slowly under forces that never sleep. Picture a solid surface that should not have weather. No rain, no wind, only liquid metal pressing and dragging in darkness. John Vidal of USC said they found evidence that the near surface of Earth's inner core undergoes structural change over time. That sentence is small enough to fit in a conference room. It is large enough to make the floor feel temporary. Vidal later told Smithsonian that the inner core surface is moving in ways scientists had not detected and still do not understand well. There is comfort in distance. 3,000 miles sounds like a locked safe, but every quake is a finger tapping on it. The tap leaves the South Sandwich region, dives through the planet, crosses the core, and rises somewhere else, faint and changed. The Nature Geoscience authors described annual, scale variability in both the inner core's rotation rate and its near-surface deep behavior. Annual scale, human scale. The kind of time measured by leases ending, children growing, old cars refusing winter in driveways. We like the deep earth old, slow beyond us, too ancient to notice our brief lamps burning in its crust. The data confounded Vidal at first, as reported, because some matched earthquake pairs behaved as expected while others did not. That is how unease enters science, not through thunder, through a mismatch, a familiar signal coming home with a different coat. The researchers compared waves that traveled through the inner core with similar waves that stayed outside it, separating deeper changes from ordinary noise. That comparison matters. A house makes many sounds at night. Pipes tick. Wood cools. The trick is knowing which sound moved. Here, the sound came from a place without air. No footsteps, no rooms, just pressure, iron, and an old boundary shifting. Reports emphasize that these deformations appear at the boundary between the solid inner core and the surrounding liquid outer core. A boundary is where rules change. Ice to water, doorway to hall. Here, solid iron meets liquid metal in permanent night. Nature News noted the work supports the idea that Earth's mysterious inner core really is changing shape over time beneath us. Changing shape. The phrase feels too simple. Like saying a sleeping face turned toward you in the dark without sound. No one has seen that surface. No camera descends there. No lamp survives. We know it by arrivals, delays, and tiny distortions. The authors called the deformation interpretation tentative, tying the variability to rotation changes and local processes near the inner core boundary. That word matters. Tentative keeps the lights on. It means the evidence points somewhere, but science has not locked the door. Still, the image remains. A dense metal sphere. Its skin tugged by currents. It's turning just out a step below. ScienceDaily reported that the findings may improve understanding of how the inner core interacts with the outer core over time. That interaction matters, because the outer core is not still. It convects. It churns. It carries heat and electric motion. It is important not to turn this into prophecy. The paper does not say your street is doomed, or tomorrow will split open. Consider holding two thoughts together. The finding is not a public danger warning, and it is still deeply strange tonight. The fear here is not disaster. It is intimacy. The planet has an interior life, and our instruments caught it moving. Earlier related work had reported multi-decadal variation in inner core rotation, and this study adds annual, scale near surface variability to the picture. Multi-decadal was easier to keep far away. Annual comes closer. It shares a calendar with birthdays and unpaid bills at home. The earthquake records used in the analysis came from decades of seismograms, not from a single unusual event by itself. If you follow science news, look for careful language. Suggests, may, tentative, consistent with. Those words are not weakness. They are guardrails. Guardrails matter in the dark. Without them, every basement hum becomes a monster and every headline becomes a siren outside. Smithsonian reported that the inner core's deformations seem to occur where the solid iron ball meets liquid metal below us. There is something almost domestic about it, a surface pressed by a restless neighbor. A wall breathing because the room beside it moves. Except the rooms are planetary layers. The wall is iron. The neighbor is a sea of molten metal, stirring without a moon. The study's signal depends on tiny waveform differences, the kind researchers find by aligning many records with patient precision over years. Patient precision is its own kind of haunted house. You sit with the same trace until one familiar corner refuses to line up. If stories like this keep you company after midnight, a quiet follow, or like helps the show find another sleepless listener, the authors do not claim a direct effect on daily life at the surface from these observed inner core changes today, and yet daily life rests on it. Your shoes by the bed, the glass of water, the ceiling fan turning above you. Under that quiet room, under roots and cables and buried pipes, an iron surface may be rearranging itself by fractions. Nature Geoscience published the paper in February 2025, after years of debate over how to interpret inner core seismic changes properly. Debate is not failure. It is what happens when the only witness speaks in tremors, and every answer passes through rock. Nature's news coverage described the result as a direct indication that the inner core's surface can change shape over time. Direct indication. Not a photograph, not a sample in a jar, tremor returning with the wrong crease in its coat. The planet did not announce it. No red sky, no cracked moon, just the archive, waiting for someone to notice. One approach is to read the original reports slowly, then compare summaries. The careful parts often live between the loud parts. Tonight, the careful part is this. deep beneath us. Something solid may not be as fixed as we needed it to be. Maybe the floorboards stay still. Maybe the refrigerator clicks once more. Maybe nothing in the room changes at all tonight. But 3,000 miles down, beyond light, beyond weather, the heart of the earth keeps receiving pressure from the dark. And in the records, somewhere between two almost identical earthquakes, its old shape does not quite come back the same.